Okay, so now we've got all kinds of information about this silly function. Okay? So we can put it on a graph. We can put x equals 3 here. And here's our axis of symmetry. And we've got 2 zeros, so we know that the graph goes through the x-axis. Because of course the graph could be all the way, it's a parabola, so it could be all above the x-axis or all below the x-axis. Okay? So x is negative 7.1 or 1.1, so those are the zeros. Uh-oh. I should look and perhaps even think before I go on axis of symmetry, because it ain't going to be halfway between my zeros, because we've got a 0 way over here and 1 here, right? Probably would have been safer to put in my zeros, but we don't always have zeros, and we always do have an axis of symmetry. Okay? Whether you got real zeros to the function or not, you've got an axis of symmetry. So, now we'll put negative 3 here. Okay, then, at 1.1, and at negative 7.1, we have zeros. Okay? So what does that tell us? Well, among other things, the axis of symmetry better be symmetric with those zeros. Okay? Which means what? That this number had better be halfway between this number and this number, right? And another way of saying that is this coordinate, the negative 3, should be the arithmetic average of negative 7.1 and 1.1, right? Well, if you add negative 7.1 and 1.1, you get negative 6. Divide that by 2, you get negative 3, so it confirms. Okay? And you want to do that confirmation. You don't want to have a graph like mine was going to be. Okay? Where I left the negative. I didn't leave the negative off here, but I got all carried away and just used a 3. Okay? So now we can draw the parabola. Probably look something like this. What else can we do? We can find the y-intercept. And I'm using notation, I'm writing that as 0 f of 0, because this is f of x, right? And f of 0 is what you get when you put 0 in for x. And that's negative 8. So this point should be 0, negative 8. Okay, so if that's 0, negative 8, what's it look like the y-coordinate of the vertex ought to be? Got to be positive or negative? Here's the vertex. Y-coordinate's got to be negative. Going to be greater than negative 8 or less than negative 8? Well, greater goes this way and less goes this way. Is it this way from negative 8 or this way from negative 8? You can point as long as you use the right finger. Huh?
Less than negative 8?
Yeah, it's less than negative 8. It's a bigger negative number, right? Okay. So what do you think it is going to be? Like maybe negative 1 million? Think that's about negative 1 million? No? Well, okay, you don't like my estimate, what's yours? Well, how many -8s does it take to get down here? Can you get there in 2 -8s? If you go this far and then this far, are you down there yet?
-20.
I can do that. If you do 3 of them, I think maybe you're a little bit lower, so -20 is probably a pretty good estimate, okay? Now, that depends on whether I do a good parabola, whether that estimate really plays out well or not, okay? So, estimated vertex, we're going to say, is about -3, -20. Okay? Actually, f of -3, which will be your y coordinate there, right? Plug -3 into the function, is it's actually -17, which means it's not too far from -20. So if you combine my graph with Brendan's estimate, we're doing pretty good, right? Not too far off, okay? Of course, assume I did the arithmetic right. I think I did. Actually, that's -16, isn't it? How do I get 17? 9 and 18. Never, that's 17. Losing it here. Okay, got it? I'd do 9 minus 18 and get 8, -8. Got -8, right. Okay, vertex is -3, -17. So we can do all that. It doesn't matter what function we have, okay? Now, if we get a negative under the radical, what's happening? Well, square root of negative is not a real number. It means you don't have real zeros, right? Okay? So we'll make a little note. If we get the square root of a negative number, then there are no real zeros. The graph doesn't touch the x-axis. Okay? But the axis of symmetry is still x equals -b over 2a. Okay? Okay, well now, we want to see how we can get this graph as a transformation of the graph of y equals x squared. Okay? This much is pretty straightforward. Transformations, you know, especially vertical stretches, are still bothering some of my students, most of them. And we want to see about the vertex form. Now, you can get the vertex form by memorizing formula, but it doesn't help you understand transformations. So, transformations and vertex form, okay? Our picture is, we've got a graph of y equals x squared, and we want to transform it from a combination of vertical stretches and horizontal and vertical shifts to get the graph that we have here. Okay? Now the graph that we have here actually has zero, zeros are further apart, but you get the idea, right? Okay? So I'm not worried about the y-intercept and the zeros of the shape of the graph. Okay? So, vertex shifts -3 units in the horizontal direction, right? Okay? Now, there's a little mystery maybe about what the vertical stretch ought to be, but since the coefficient of x squared is 1, that means you don't have a vertical stretch. Okay? You don't have to stretch it or anything. You just got to move it over and down. Okay? So we'll see why that is. We'll talk about that. But right now, I don't like the way I started those things, I'm sorry. Y equals ax squared. Multiplies the y-coordinate of x squared by a. Which moves every point absolute value of a times as far from the x-axis. leave myself room to write the rest of it there. I'm gonna try anyway. And if A is less than 0, on the other side of the x-axis. Okay? And you can verify that just by making a little table of x squared and then ax squared for whatever number a you want to use. Okay? Draw the graphs and see at each point moves the way I said it does. Okay? Y equals quantity x minus h squared. We're having a little trouble with this statement there. Okay. I don't see a way around this right now for positive h. There are more mathematically precise ways to state this, but they'd be confusing. At least I can't think of one that isn't. Okay? Doesn't mean there isn't one. So if h is positive, what I'm saying is, okay, let's say you do y equals 7 squared. Let's say x is 7. Okay? Then what value of need to go back and say h, let's let h be 7, okay? So let's let h be 7 and let x be 10, okay? So if we square 10, we get, no surprise, 100, right? Easy to square. Now, what would we have to square here if we wanted x minus 7 squared to equal 100? X would have to be 17, wouldn't it? Because then 17 minus 7 would be 10, and we'd be squaring that, okay? And that needs to be written out. Too much like this, so. Okay, if x is 10, then y equals x squared is 100. Okay? to get the same y value for x minus h squared, and h being 7, that would be x minus 7 squared, it should be pretty clear you got to let x be 17, right? Okay? So the graph of x squared contains the point 10, 100. And the graph of x minus 7 squared contains the point 17, 100. And that graph, that point is 17 units to the right of this one, right? So you can draw that. So you got the point 10, 100. And to get this point from this one, you got to shift it over 7 units to the right. And that's true for any point, any value you want to put in for x in the x squared function has to be 7 units greater in order to get the same value in the x minus 7 squared function. Okay? So, don't want to go too much further with this because it's not easy to understand, but the graph of you can generalize what I said here and conclude that the graph of x minus h squared is shifted h units to the right if h is positive, okay? And of course be h units to left if h is negative, so it shifts it in the opposite of the direction it's going to look like. Okay, now you got the rule. You've seen the rule. If you understand the rule, you're going to be less likely to misapply it because I see that no matter how much we stress the rule, people still tend to mess it up. At least a significant number of people still tend to mess it up. So, I don't like just the rule. I like at least having an example that shows why the points on the y equals x squared graph are matched by points on the x minus 7 squared graph that are 7 units to the right. Okay? Then graph of x squared plus k points, the y coordinates are changed from the x squared graph by k units. Graph shifts vertically k units. All this should be generalized. Most of the whole statement I have here, the graph moves every point, whatever f of x is. Whether it's the x squared function, the x cubed function, the reciprocal, 1 over x function, 1 over x squared, square root of x, 2 to the x, any of the basic functions, or any other function, doesn't matter what f of x is. If you multiply its value by a, that moves the point a times further from the x-axis and on the other side of the axis if a is less than 0. It's usually stated as a vertical stretch, and if a is less than 0, there's a reflection through the x-axis. Okay? A does both of those things. But it doesn't reflect unless it is less than 0, so half the time it only moves in the same direction. Okay? Moves every point k units in the horizontal direction. And every point k units in the vertical direction. Now we come back to our function. Every point has the same horizontal and vertical shifts, okay? The vertex of the y equals x squared graph is on the x-axis, so no matter what a is, it's going to stay where it is when you do the vertical stretch. Okay? In this case, you don't have a vertical stretch, but it doesn't matter. The vertex is going to stay where it is when you do this. Because a times being at 0 distance from the x-axis leaves you at 0 distance from the x-axis. The horizontal and vertical shifts are just going to be the numbers that you got, right, from the quadratic formula. Okay? We found the axis of symmetry and plugged that number in, you know, the x-coordinate of the axis of symmetry, plug that in to get the y-coordinate. Okay? So the vertex tells you what the shifts are. Then you just got to worry about the stretches. And that's easy, because if you've got a quadratic function, the number in front of x squared is going to be the same for both. Okay? I'm not sure that made sense, but then, yeah. Whatever's in front of the x is your vertical stretch. Sorry, whatever's in front of the x squared is your vertical stretch. So, okay, for this one, h is -3 and k is -8. Using the f of x notation, because this is always true. Okay? Uh-oh. I used f of x for this function, so I can't use it for the x squared function. So g of x is going to have to be, we're going to have to use g of x instead of f of x here. That